So on to problem number 18 of the MIT integration book of Frank 18, which is the indefinite integral of 1 over the square root of x times the square root of x minus x squared. Now this is actually a slightly trickier problem, but all the same, let's enjoy how to solve it. This is our problem, right? The integral of 1 over square root of x times let's shorten this a little bit, so it's the square root of x minus x squared. Okay, so one thing we may be able to do is, again, what I'll do is I'll focus on the denominator and pull out the x squared, so that when the root sign comes into effect, it becomes x outside, and that means that we have 1 over x, because this guy here is not x squared, so we had to force an x as a denominator, and this becomes x minus 1. So, and this now becomes, I can now pull this guy up, so we have a square root of x. Maybe not that fast, so let's do something. Well, let's go so much into the details of what needs to happen. So we have x, and then square root of x divided by x becomes 1 over square root of x minus 1, and this becomes 1 over x over square root of 1 minus square root of x over square root of x. So and so, since we now have the integral of 1 over square root of 1 minus square root of x over square root of x, this guy now can go up, and so this becomes x to the power a quarter over x 1 minus square root of x dx. So we can express everything in terms of exponents. So this is square root of x, the same as x to the power a half. And so let's try and see. Let's get these two to interact, so that we do now have x to the power negative 3 over 4 over the square root of 1 minus x to the power a half. And we can express this as x to the power negative a quarter to the power 3 over x minus x to the power quarter squared. So I think it's easy now to just substitute, and we could just say let u be equal x to the power quarter, so that du dx is equals to a quarter x to the power negative 3 over 4. And that means that du is equals to x to the power 3 quarters dx. So this is an important variable to hold at hand. So we have x to the power negative 3 quarters over 1 minus x to the power quarter squared. This is the same as, so this part here becomes 4 du, and then we have 1 minus u squared. Now this is easy, so we'll say let u be equal to sine theta, such that du d theta is equals to cos theta, and so du is equals to cos theta d theta. So this is important, so that we have 4 du over square root of 1 minus u squared is going to be equal to 4 cos theta d theta over 1 minus sine squared theta, and this part here becomes cosine squared theta, square root, it becomes cosine theta as well. Right? So those cancel, and so our problem becomes the integral of 1, which is 4 theta now, plus c, and since u was set to sine theta, that means that theta is equal to arc sine of u, so our problem becomes 4 arc sine of u plus c. So since our problem is 4 arc sine of u plus c, but u was set to x to the power quarter, so in other words, our problem 1 over square root of x times the square root of x minus x squared is equals to 4 arc sine of x to the power quarter plus the integration constant, and that is our answer.